Hello everybody. My name is Roy Sable. I'm going to be co-presenting with Todd Alford today about the Model Assessment Toolkit. It's a new feature for CFD 2016, and so far, in all reality, we really haven't seen many people ask many questions or get a whole lot of feedback on it. So before we even get anywhere with presenting the toolkit, I just want to ask a simple question. Have you tried it out? Have you seen it but just didn't know what to do? You didn't really do anything, or you've barely even used 2016 if at all, and you didn't know it existed, and just getting some more information. And for the people that do write yes, if you can add in some comments. Heath is online. He's the product manager, and I know he'd love to hear how people are using it successfully or not successfully. So right now we have a good amount of people voted, and what I'll do is just share that so everybody can see the outcome. So there are actually a fair number of people that have used it. I lost the screen. That was actually weird. You guys still hear me, Todd?
Yep.
Okay, sorry about that. There we go. Great. So again, we'll be diving into that a little more. Todd's going to be doing some demos. So if we go into the next slide, Todd. So just to remind everybody, the Autodesk Help webinar series is a large program. This is just one of the webinars. This is the CFD Build Your IQ series. Mostly it's monthly, and it's hosted by people within the technical support team. Typically about 20 to 40 minutes. Some of the most popular webinars, which are posted on YouTube for you to watch, are the turbulence models, rotating region, and the free surface best practices. The next webinar we'll be hosting will be July 29th, and this will be looking at leveraging the updated Decision Center for 2016, specifically around electronics cooling. So in terms of new knowledge articles that we've written in the past month, the one at the top is actually an ongoing one just to remind everybody how the Flex offering has changed for 2016. Otherwise, when you download this presentation later, you can come in here and look at these new articles. I think one of the more interesting ones just to be aware of is if you are still using CFD 2015 and as well as email notifications, all of that won't work anymore because the whole back end has changed for how the notifications are handled. So that feature just doesn't work. You need to go to 2016 to leverage that moving forward. So at this point, I'll hand it over to Todd so he can do a deeper dive for you guys.
All right, guys. So today I wanted to really give you a better run through of what the model assessment tool is, give you a good idea of all the features, and, explain, do you need to use it? What is it going to do to your model? And then what is actually happening in CFD during the launching process, because we didn't have this tool before. And then just give a quick example model and kind of show you guys through some of the features. I don't know why. There we go. Apparently I had a little animation in there. So what is the model assessment tool? It's essentially taking a look at your native geometry when you're launching into CFD to take a look for problematic features. You can really use it to verify if your simulation ready, or if you might have meshing problems or just too much mesh. Really all that we had initially back in 2015 was you'd see this little down in the message window, the edge merge tool may provide useful help to you, or the small object removal may help. And they showed up, they didn't really tell you if you needed to do it or what was going to happen. Now we actually have the ability to really look at all of the areas with a full brand new UI. And when you're diagnosing some of the problems that you run into, it can be really helpful, or you can make better geometry to start with. So to really look at all the features, I think everybody should probably relatively understand edge lengths. It's just looking for small edges, because that's how the mesher works, is it's looking at where your edges are, how many nodes it's going to put across edges. So if you see some really tiny edges that are getting created, maybe not even on purpose, just because of a sweep or something like that, you can go back into the CAD and kind of clean that up. It definitely happens a lot when you're working from production geometry that you're getting from a customer or something like that. Sliver surfaces can actually point out if you have just a small area on a large surface. It'll happen a lot what I've seen with electronics boards. I don't know if, Royce, have you seen a lot of that where, maybe a chip is near an edge or something like that where it creates a sliver surface out of a large surface?
Yeah, I've seen that many times, especially when you have a chip going along an edge on a very large board and there's a small gap or small sliver kind of hanging either off the chip or maybe kind of where the chip doesn't quite line up with the edge of the board. Those are sometimes hard to really see or notice until you actually bring it into a tool like this.
Yeah, and the other thing that you can have is just kind of like an arc where it makes kind of a triangular surface that comes to a point. Fillets and things like that can cause all kinds of weird anomalies at the very end of something. Part gaps is like if you had a cut for an O-ring or something small like that where there's just a little gap that is internal to the part. And I actually kind of screwed this up. It was the model slivers is where you find what Royce and I were talking about. And there's actually an example in the help showing you with the electronics box where just two surfaces, the imprint causes, the imprint is created by CFD, and that'll create a sliver surface. And there was really no way to spot that unless you were using, maybe the mesh diagnostics could point it out. A model gap is actually when you have two parts in a model that have a really small gap, and it'll look for that gap and tell you it's there. So maybe you just want to extend a surface to get rid of a really tiny gap. If you've got sheet metal or something like that, can cause it a lot of times. I think interferences are pretty self-explanatory. It's where two parts are overlapping. And what happens when you go into CFD is a new part is created out of the interference. So you don't want to create this really tiny sliver interference. Again, that's something that I've seen happen a lot of times when you have just kind of a tight fit. You draw it in the CAD so that, your O-ring is larger than the little gap that it's fitting in, and then you end up with a whole bunch of new parts that are all these little slivers. Can cause you problems for meshing. So here's some quick pictures. I don't want to go too far into this. I'll show you these. The one I did want to point out, this is actually from the help, the model slivers, where we have a chip that is sitting on a larger piece, and the surface itself is fairly large, but because those two edges from two different parts are close together, that'll create a sliver on a much larger surface that we'd need to do a lot of work with the meshing there, and then the enhancement wrapping around that very tiny step. It would be worth cleaning it up in CAD before actually going forward with the model. But I'll show you guys all of these in a little live demo. So do you really need to use the tool? Not really. It's there for your benefit. You shouldn't consider it as something in your way. You can cancel your way out of it, or if you're doing a new design study, you know, the different launching methods, you can get around it a couple of different ways. If you really think that your model's good to go, you created it from scratch, and you don't really want to go through the tool, you can just transfer it to the setup, or you can hit cancel and come right into CFD and work just the way that you did before. Where I think it's really useful is, you know, if you thought you were all good and you're running into meshing errors, you can really use this as a diagnosis, because it'll point out the small features in the original geometry to really help you out. You know, when you're actually in the UI for CFD and you hit create a new design study, it has this little checkbox there for import into model diagnostics. That actual pop-up does remember your last checkbox, so you can have it unchecked, and then you'll pretty much always be bypassing it unless you want to recheck it to bring in a certain model to look at. When you're jumping out of CAD, there's, you know, being able to launch into an actual model assessment tool, or you can go about what you had previously. The active model will bring you straight into CFD.
So whenever you're actually starting a new project, I'd always just load in quickly with the model assessment toolkit, take a quick look. Or to me, I think the better workflow, especially when you're starting off with a new project and you need to defeature, make it simulation ready, is to consider more of a divide and conquer approach, to start looking at the most problematic parts and using some of the first few features or options you have in the model assessment toolkit, because that will allow those smaller parts to load in a lot quicker, because now you're not doing part-to-part gap assessments and things like that, which currently take a bit of time, but you know, we are looking to speed up, so this can be a much quicker tool to work through back and forth when you are troubleshooting.
Yeah, that's a very good point. When you're starting with raw geometry, especially if it's been sent from, you know, a customer where it's fully featured, you've got all of your serial numbers on everything. You know, this will point out a lot of where that stuff is. You can quickly go in and knock out what you see visually, but then when there's a bunch of stuff hidden, this tool will make it a lot easier for you to find and fix it.
Yeah, and also just be aware that this kind of essentially locates a bunch of different tools. So that right now what Todd is showing is the old diagnostic window, which he'll be talking about. But, you know, this now, a lot of these tools are now within the diagnostics toolkit, so that you're not jumping around from maybe leveraging something from like the small object removal or edge merge, or coming over here to diagnostic. It really brings in all those options plus more.
The one thing with that, though, so the model assessment tool isn't going to modify your geometry for you. It's really there to show you the problematic areas of it. You know, you could still use the edge merge, because once you come into CFD, all of those tools are still available, but you know where there were a bunch of small edges, you know, maybe some arc got broken into 10 lines. If you see that in the model assessment tool, oh, I can get around that by using the edge merge. Does that seem correct, Royce?
Yeah, no, I agree with that. Okay. There's definitely a lot of room for using your own engineering judgment. Okay, you know, I know that's going to work fine, or wow, that really surprised me. I didn't think that was there. I should definitely clean that up.
Yeah. But yeah, if you went into like our old meshing diagnostics and you just looked at it, it wasn't doing anything. You'd have to either modify your minimum refinement length or, you know, save all of the sliver surfaces and try and tighten the mesh on those manually or by grabbing them one at a time, you know, and it didn't isolate anything for you, which I think the new model assessment tool does a very good job of. You know, sometimes you just don't know what you're looking at or why it's a problem, but as I do my little live demo, I think you'll see how I can get you to where the problem is a lot faster. I also wanted to talk a little bit about what happens during the launching process. What the model assessment tool is looking at is your unaltered CAD geometry from your CAD package. It's not doing you know, the full conversion that we normally do when you come into CFD. Because normally when you jump into CFD, shared surfaces are created as one surface. Your interfering parts will create new parts for the interference, and those surface imprints that we were talking about earlier are all created. So you'll see a couple of things. You know, I have kind of an interesting thing to show in my little demo here about trying to show where we might have problems with the surface imprint, but it may not necessarily be there because of the way that it does a search. But I'll get into that in a second. Let me, before we hop into questions, let's bring this guy up. So here I just have a little connector, and you know, it's fairly complex, a lot of small curvatures and tight gaps, and you know, this is something I wouldn't have wanted to bring into CFD, but as a fairly complex part, I could see somebody having this as something that they would send over that's attached onto a board, or you know, any number of geometries where they have something that's fully featured and we need to get it down to being simulation ready. So just to launch the CFD model assessment tool, and this is SimStudio, by the way, that comes installed with CFD unless you choose to not have it installed. So when we launch in, it goes through all of our, you know, all the different parts that we had talked about. And we can go in, here we have, you know, where the potential model issues are. They're not necessarily an issue, but it's going to tell us what, you know, all the different places that we may have problems. So I lost, there we go. So I wanted to show you guys, when we're looking at edge lengths, it's kind of funny how a lot of these will actually kind of work off of each other. Right now, it doesn't really help you too much because there's a very tiny edge in this model that's highlighted. But I can set the auto zoom and it'll go and find that edge for me. So I can look at the model and see, oh yeah, there's a small edge. And if I actually look at the sliver surfaces, and I go to 2, oh, it's on the other side. I thought I got the same one. But we have the same thing where there's just a little round there that really isn't going to do us any good in simulation. I could go in and delete that, get rid of a couple of edge issues, and probably get rid of a couple of sliver surfaces. It should help out in the meshing process. So if you guys remember, the part gap is when I have the same part that has has a small gap in it or a cut. So if I go to 20 was a good one. So here I have the same part, and there's this small little gap cut around it where I'm probably not going to be worried about the airflow in here. And yeah, I can see why that's going to give us some trouble when we get into the meshing phase. So we might as well probably just close that off. I will let you guys, well, I guess I can show it. And you can look into the help. There's a lot more information for all of these things. I don't want to completely overdo it just to waste anybody's time. But if you look into the help, it talks about the different issues, and here's where we talk about the model slivers. Basically, these chips are not the same size as the pad below them, so it points out that when we're looking at, or when an imprint gets created, there's going to be a sliver surface. So that's what you would get out of the model slivers. In this model, because I don't really have any parts that overlay on top of them, a lot of times you'll see basically where the gaps are again. So that's one thing, and I just found this while I was doing my search through it, but you still see the gaps again, and it can be fairly helpful because it's really looking at an edge difference. So then if we go into model interferences, show 7, or model gaps, I'm sorry. So here I had left, this is actually a separate part. So we can see that between those parts, there's going to be a very tiny gap, whereas the other side that we were looking at that had the same thing, I just merged the two parts so that it was one. But after we've gone through and we saw everything, if we thought that this wasn't too bad, we could just transfer into the setup and just make this live model. And I'll probably put this up for you guys. I just got this out of GrabCAD. I believe it was an Arduino model that I grabbed one of the connectors off of just to show, because it was detailed enough. When you launch in, we still have the geometry tools pop-up is still there. It popped up on my other monitor, so if I close that and I say that everything's going to be a solid just for fun, and I'm going to clone my design because I've already done clean connector. Let that load up, and then I'll actually mesh this guy just so we can see kind of where the benefits are when we go back and we actually take care of cleaning up the geometry. That. I'll auto-size it, and then generate the mesh. Go for it. So now the other model that I did, I had gone in and I deleted some of the really small rounds that created some of our problems. And I forgot to show you guys actually the full count, which I'll show you with this one. But got rid of some holes and some other things. Just quick pull some surfaces. I spent maybe 10 minutes in SimStudio because it's pretty easy just to grab a surface and then I can hit delete and it'll get rid of things. So a lot of them really that's not a good one because it tries to take these since they're not parallel and run them out. But a lot of the little features, I just hit delete and it'll clear it up. You can use, I really like this simplify tool because it'll get rid of a bunch of holes and features and things like that for you. Doing some consulting work, I use this a lot, and it'll catch a surprising amount of things. But we'll launch into the model assessment tool with our new cleaner geometry here. So as we look through it, we actually see the potential model issues for each given area that we look through. I believe we had 24 small edge lengths that were captured by the tool. And you can actually change what the tolerance is for what it's going to catch. All of that stuff is something that you can modify to go look at things. Really where we saw the biggest improvement of what I was cleaning up was the sliver surfaces. If you looked at this number on the previous model, it was actually 160. So 10 minutes of just focusing on where the sliver surfaces were, I dropped that number down to 39. The part gaps, I think I got rid of about half of them. The model slivers was another one that had a really high number that I dropped down to 1. And the model gaps, I think, was in the 20 range, and we dropped that down to 2. I created an interference just so that that button would be, so I could show it to you guys. It just shows, basically, I'm going to get a new part when I bring this into CFD that is this shape. If this was something really tiny, then we could have some serious meshing issues. And the other thing that'll be goofy with some of that stuff, because it's a CFD created part, when we transfer it over into the setup, I'll just show you this. You know, now I have a part that it doesn't know where to apply something, and really until I'm starting to hide things and look for where things are, because I got rid of 2 or 3 parts, and now I'm down to just 2, and this is a new part, so it doesn't get, well, it actually got the aluminum, but I end up with something hanging in the tree. So you always, when you're doing that update, you need to make sure that everything's set. It tagged me when I went through and ran this guy. But we'll go over and we'll hit the mesh auto size, and we'll generate the mesh on this guy. Yep. And while that's running, I'm going to run back and take a look at what we got for our mesh on this guy. If we look in the status file, we can go and see the actual element count is 229,000 elements for this one part, which fairly believable. There's a bunch of small rounds and things all over the place.
Hey, Todd. This is Heath. Can you hear me?
And, you know, what's that?
I was saying this is Heath. Can you? Could you turn on the display of the mesh for people? I want to point out one thing real quick about the type of information the model assessment toolkit is, supplying people. Just, show the mesh display or whatever.
The display of the mesh.
Okay.
You want to see the shaded mesh?
So,
or back in the...
No, that was perfect. That shaded mesh was exactly. Because the actual end result of what the mesh looks like.
Oh, okay.
Yeah. The one thing I want to point out to everybody,
Gotcha.
and sorry for interrupting it, I hope it's not rude. So when the model assessment toolkit is working through those assessments. The thing that it is displaying is not necessarily that your model won't mesh. It's more about, we want to give you the most efficient simulation model that we can so that you can work through these designs on what is important, which is the multiple designs and looking at improving the product or whatever. So in this case, what I have found is that if you look at the small edges, sliver surfaces, and model slivers, part slivers and model slivers, those typically will still mesh. It's just going to cause an unnecessary concentration of mesh element, typically where the model assessment toolkit is pointing those things out. Now, for part gaps and model gaps, those are areas where typically you would have a fluid, and if the fluid gap is way too small compared to the rest of the mesh size of the model, then you might have a mesh failure. And so that's not an absolute. It's not saying that if you have a small edge or a small sliver that it will always mesh, would just be concentrated, but that's more than likely the case. And it's not to say that these small part and model gaps won't mesh just because they're small gaps. The mesh is pretty robust and surprise you. But what will always happen is that you will at least have more mesh in those areas than probably is necessary. One thing that I think users may have run into based on some of the comments about taking a long time, you can stop the model assessment toolkit midstream if you want. You can hit the cancel operation and it will stop immediately. So if you want to just bypass it, you made a mistake, maybe you didn't mean to launch that whole model into the assessment toolkit, there's no reason to have to wait. And it will actually work while you're looking at the model. So if some assessments have completed and there's others that are still working, you can look at the ones that have completed while it's still calculating the other assessments. Anyway, I just wanted to kind of add that commentary so people can kind of get a better understanding of how I've used it in the past.
Oh, absolutely. Yeah. That's actually a really good point, because I meant to kind of point that out, because here I'm showing that a model will mesh in either way, and even the small gaps that we had, the mesher will still do it. I've put a fluid around this. I just didn't feel it was completely necessary because it takes a little bit longer to mesh.
Right.
But yeah, when you look at the edge lengths, they're very highly concentrated around these pins, which I actually kind of deleted some of the curvature. And then I got rid of, where did we see those? These little slivers. When you look at the model zoomed out, we see that the mesh gets really tight over by those corners, and then it'll grow out to areas where there's just not a lot of features. This being very thin, the mesh is still relatively fine, but you can see all of the areas where we start to get very small elements. Thanks a lot for stepping in there and helping me with that, Heath.
No, that's cool. And the only other thing that I would say is that the only other thing that I would tell the audience is that when we're in the assessment, I would very liberally go and change the definitive number that points out the sizing information in the model assessment toolkit that points out possible or potential problem areas. So if it says 0.003 millimeters, for instance, as the threshold, and you know that, for instance, well, I don't care about any edges that are over 0.002 meters, anything under that, so I really care about, change that threshold if you want on the model assessment toolkit, because it's meant to be an engineering tool, not necessarily a hard and fast rule. It gives us a good point, but not necessarily knows everything that's supposed to be there. So that edge length, I would use that liberally to really point down on the what I would consider the most probabilistic.
Right now we have 18, and if you modify the range.
Yeah, that'll modify your legend, obviously, and then the edge length itself will change the figure down. So if you see something that says I have 1,000 issues, maybe that edge length is a little bit bigger than what it needs to be for the overall model, and you can point it down to the most probable, if I could stop stuttering, probabilistic offenders,
Right.
if you will. Anyway, I'm done. I won't interrupt you more. Well, thank you for letting me talk a little bit.
Yeah. Yeah. Absolutely.
Hey, Todd, can I?
No worries.
Todd,
You
is it
hop
okay
in
if I?
any time.
Todd, is it okay if I present something? This is actually from a forum post. It just kind of crossed my mind. This is a good example to share, and it's actually a large model. So I'm just going to steal the show for a minute, since we got time.
Hold on a second. Let me show my mesh count. Let
Sure.
me show my mesh count. I want to show everybody what we actually did. So yeah, we dropped the element count just by doing some of that stuff down to 113,000 elements when before we were at 228, 229. And again, to Heath's point, we don't have quite as tight of a mesh on the corners. And even though you can't see it quite as well, these connectors are a little bit coarser meshed as well. All right, now I'll let you have it, Royce. Let me throw you the ball.
Awesome. I'll steal it from you. There we go.
There we go.
So I'm going to show my... Okay, do you guys see my screen? See it, Todd?
Yep.
Excellent. All right, so this is actually a forum post, and it didn't come in initially as a problem in terms of geometry. And when you start looking at this model within Revit, for instance, obviously this is a very large building. It looks really clean, and nothing really jumped out at me. And they're actually having problems using the solar window approach. Once they turn on radiation, it's a little unstable. Not solved yet, but one thing I did notice once I actually used the model assessment toolkit was that I went into model slivers and part gaps, because a very common issue with Revit models, especially when we look at CFDs, sometimes we see some very small overhangs or very small overlaps or little gaps around the windows and doors or walls, specifically walls. So I wanted to see what would happen to this model once I start looking at model slivers. And what I ended up finding out right away is that, okay, it captures these little overhangs with the windows. That's fine. I'm actually okay with that. They're just having a little bit of an overlap right in here where the windows don't quite line up with the walls. Doesn't bother me a huge amount. But what did jump out at me right away, so if I zoom back out here, is you can start seeing some purple start to show up along the walls and right along maybe the third or fourth floor here, as well as right over here in this zone. So this is starting to tell me that I have some very, very small overhangs, because even if I were to zoom in right in this region, I don't even see it in this view. Once I actually load this into CFD, you can see it. It's just that this is taking a little bit of a different point of perspective. The other thing that really starts to jump out at me once I start bringing in this tool is that, these human models that are in here, great, I love the humans, but this is a very large model, and then we start getting the external domain that the customer would want. Now we're talking a model maybe this large around that. So, because now when I start looking at my edge lengths and look at the smallest parts in this model and start zooming in, what I end up finding out is that really the smallest edges in the model are right along the human. Like, look at that little edge in there on his shoulder. This model could definitely use some simplification of the human model to make everything a little bit more easier for meshing and so forth. So basically everything down here, so this is a 0.165 millimeter length, and right now this is at 20, so if we were to modify this range down to, say, 1 millimeter for this building, which is pretty large, let's bring this down to 1.
Still 100 issues.
Still 100 issues. And now if I were to zoom out, I can't even see those with the color coding, because we don't put arrows in because that would get very distracting. but you can just start zooming in and seeing all those. Same with the surface slivers. If I were to go to that assessment and go to my smallest ones, you just start seeing these humans just light up right along the shoulders and around the waist area. And that then tells me, before I even start setting up this model, because actually this would take quite a long time to set up for all the windows and doors, that, hey, I should go back to Revit and kind of take another look at this. Okay, so I just wanted to share that. It's something that crossed my mind about this model when Todd was presenting.
One thing to let the users know is that they can multi-select in that chart, and if you do auto-isolate, it'll actually show you all the parts that are the offending parts. So you can see, right, real easy. It's all those small things, they're on the bodies of the mannequins or whatever. Yeah. So that's a kind of a technique. You can use the visualization options to your advantage. Boom, they're all on the avatars or whatever. Anyway, just another way. The tool is brand new, and there's a lot of functionality in there. We tried with the help. I think I'm going to start posting stuff on SimHub videos on how to use it. One thing for all the audience attenders to also know is that this is really a foundational thing. We're concentrating on geometry and meshing really heavily, multi-year plan, and some of the information here will get used in some more automated tools. But right now, it's more informational for this release.
Here's just another example with model gaps. If I look at my smallest model gaps, and this is 0.02 millimeters basically, that is some pretty small gaps for a model this size that really should be examined. And trying to dive into this with older approaches would have taken me a very long time to discover that with any one of our tools that we had previous. Eventually, I might have found it, but it wouldn't have been a fun experience at all.
Yeah. Right. Probably like getting ice cream.
What's that?
Ice cream would have been a
hopefully you get.
Yeah. I'm not sure what that is. So, anyways, I just encourage you.
Maybe you'll get a crazy nodal aspect ratio if you're lucky.
Yeah, that's probably what I'd end up having to do is, if people aren't familiar with that trick, is basically turn off mesh enhancement, and I don't know how long this will take to transfer, but if you turn off mesh enhancement and turn on the stream function result, that enables nodal aspect ratio for a 3D model. The stream function is actually a 2D output, and then you can put like an ISO surface in here and switch it to the nodal aspect ratio result and just find your most deformed elements in your model, and then just start zooming in and discovering things that way. Great diagnostic tool, but it requires not a lot, but going through a few different steps to finally get to that, and then waiting for it to mesh if it's a complex model.
I was going to say that can be a long process because it could be 20 minutes an hour on meshing.
Okay, so Richard brought up, can we bring in an STL file? No. I guess SimStudio can read an STL file, right?
To a certain size, yeah, there's a certain polygon limit. Well, actually, you can read them, I think, unlimited size, but the one thing to realize is that STL files are not a format that is explicitly supported in 2015. It's a faceted model. There's no solid geometry. So the only thing that can really support an STL file is if you use the surface wrapping capability.
Okay. Like here's a gnarly STL file that I was playing around with for a 3D printer. It's basically a enzyme model. So you can see some molecules in here. So you can see how this would come in. And as Heath was saying, it's all faceted because it is a mesh body. So this still wouldn't import into CFD if we were to mesh. It just wouldn't be brought in.
But you could take that into surface wrapping, the surface wrap application, and it will surface put a mesh around it, and you could use it that way. That's the only way to work with STL geometry, unless you convert it into solid geometry today. More to come on that for future releases, I can tell you that.
Oh, yeah.
Yeah, so that's what I'd have to do. This wouldn't give you diagnostics, though, when you read this back in. It just does the mesh, and that's it.
The current workflow is you actually create a mesh in this tool, so there's no diagnostics done on it.
Okay, that's what I thought. Okay, so
right now there are a lot.
That's pretty awesome. Yeah, so Jack, in terms of fixing those slivers in Revit, I'm not a Revit expert. I actually have a guy that sits right next to me who is, and I usually talk to him. And a lot of times when we do help people that have Revit issues, we point things out to them, and then they're much more experienced with the tool than we are, so they seem to do it pretty good. Simpleware, I'm not familiar with that. Heath, are you familiar with Simpleware?
No, I'm not. What kind of tool is it?
Do you have a website, Richard? Is it a CAD tool? Is it kind of like SketchUp from Google? Simpleware. For everybody that's curious. That's a new one for me. I'm assuming if you were to output out like a Parasol or ASYS or STEP, something like that, yes, we could. But I'm doubtful on whatever their native is.
Yeah, so I just read through their website. There are several different packages or add-on portions of that software, and one of them is to create NURBS geometry. So it depends on the output, right? If it's an STL, the only route you're going to have, if you only have STL, you're going to have to go through surface rafting today, or try to take that into SimStudio to convert it to a NURBS, which is solid geometry. Or otherwise, you need to add output that's a CAD-ready format.
Yeah, so at least the CAD module here, it reads in formats, and it only output an STL for 3D printing. And then the NURBS module, if we look at the technical data, exporting format, you'd have an IGES. You could use it, we do read IGES. It's not a great workflow. Yeah, it's there to use, but I wouldn't ever suggest that. Okay, so there's an evaluation. Oh, might have to check that out. Thanks, Richard. Okay. Todd, I'll give it back to you. Sorry for chiming in there. Cutting you off.
Okay. Oh, no worries. I think I mean, that definitely added more of a real-life value versus just showing, here's something nasty, and, yeah, look, it pointed me to the areas to clean up. So you've got somebody running something real.
I see here another question.
Questions? Because really that's what we're into the questions time.
Yep. So I got one here from Scott about, could you highlight the options again for interference removal at entry into CF Design or CFD, or acceptance of interference in proceeding? So we're not going to fix interferences within the tool. We're really just highlighting so that you can go back to your CAD tool to repair that. There's multiple ways to fix that within your CAD tool. If you were in SimStudio, it would be simply like a move command and then adjust it to actually align.
Combine.
Yeah, or you can combine something to Boolean operation and bring them all together. That's what I prefer especially if they're all same material. Just things are easier to set up if you have less parts to assign in CFD, so you should go that way.
There's less parts.
Yeah, a lot of people, if the interference is macro enough, not some really small sliver, then they'll keep that and just suppress that in the surrounding parts. So Todd earlier on was talking about having an O-ring, within the fitting, and a lot of people will keep those O-rings because they might just be designing flow through a valve and like, well, I'm going to suppress all the housing and the O-ring. That's okay with me. But if you were trying to do heat transfer for all that, and the O-ring really isn't affecting that portion of the result, then yeah, you would then fill that in with a much cleaner geometry, so it's not as dirty, I guess you could say. Interference removal tab. There's a small object removal
and it's tab. A good idea to get rid of that stuff anyway, just for some graphical. Right.
Yeah, so I think what Scott's thinking about...
And that's just telling the mesher to ignore it.
In essence, yeah. I think this is what you're thinking of. So this doesn't remove interferences, it removes small surfaces and small edges from the model. It's not designed to remove entire parts. And I have seen some people try to do that with the interferences, remove all the bodies of that, and more often than not, that creates more issues. Because what's going on here when you remove, for instance, a surface, it visually creates a hole in that model, and that hole needs to be smaller than the neighboring mesh that it eventually have. And if it's not, what will happen is that it basically becomes like a drain. That as the mesher tries to smear over that hole, the elements are now so small that it actually like feeds into that hole. Okay. So if you start removing solid volumes that it still thinks it needs to mesh,
well, it'll actually make the mesher fail.
Yeah, it will make the mesher fail. So that's when someone might be abusing this tool more than it should be. Okay. Some of these smaller edge merges, I guess more small objects. If I were to try to do that same overhang with the surfaces, it would eventually point them out to me. Now if we start to zoom in, you can start to sort of see that one little sliver hang around in there. So that's another way you could have found that in the past, but it may not have jumped out if you didn't actually open up this tool or move around with the slider. Because remember, this default was here, and initially it didn't show any surfaces because something else with the smallest edges, that was more of the concern. Driving down that size. If I were to now look at this whole model and find that edge, if I can, sometimes, oh, here it is. I have this extremely small edge now, probably close to what would be an overhang, right somewhere in this area. Like it's so small that it just visually can't see it, but it is there. Okay.
One thing to point out, though, is that the edge merging and small object removal are good ways to reduce mesh, mesh concentrations for those types of features, but they will never do anything when it comes to part gaps and model gaps. So, I wouldn't rely on it to remove the small stuff. You definitely are probably well off to look at the part gaps and model gaps. And I don't necessarily say that the model assessment toolkit should be used every time, especially if you already know that your model is pretty clean. But if you do run into a meshing issue, I would definitely go and run it back to the model assessment toolkit and try to find potential areas, especially the worst offenders, especially if you had a model not mesh. That's where I would definitely always go.
So I want to just go back to what Scott was asking about the interference removal. What he was actually getting at was something I didn't really think about in a while, but it's the prep tool that loads up from loading in from Pro Engineer or Creo. So there is an interference removal tool there, but that's a legacy thing because we didn't support Boolean operations reading in geometry from PTC. So there had to be some sort of tool so you could identify and clean up interferences before you launched it, otherwise it just wouldn't work. So that is a unique workflow coming in from Creo. Okay.
Oh, yeah.
Okay, so I think at this time we've probably talked more than we initially thought. We thought this was going to be a shorter webinar, so I'm glad we had some good questions and feedback. I have one user actually going to be sending us a model that's been bogging down the whole process actually because it's so large, so we can give that to the developer. So, please engage with us. This is a new tool, like Keith said. We want feedback to try to make it as powerful as possible. It also show us where it is lacking so we can improve it, especially on the speed side. But at this time, we'll end the webinar. I just want to thank Todd for presenting and Heath for coming in. It's always great to have him.